Okay, so finishing off the right-hand slap rule and F equals NILB, we have two questions. One from 2007, question 4. Question 4, and this is definitely a direction thing. In which direction, clockwise or anti-clockwise, will the motor rotate when the switch is closed? So this is just a diagram. It's a motor. We've seen this before. Now we just need to figure out how it works. So if we close this switch, what do we need to figure out the direction of the force? Remember, we need three things: current, a field, and that'll give us a force. Alternatively, if we had force and a field, we could figure out how much the current is and all these other kind of things. But we'll just start with the basics. Force. Okay? So if we close this, which direction is current flowing in? From positive to negative. So the current is flowing this way. Which direction is the field going? That way. So just put our thumb in the direction of the current, fingers in the direction of the field, and we're going down. So which way is it flowing? So JK is going down. Okay? Now, to prove to you that it'll go in this direction B, or anti-clockwise, we should look at LM. And which direction is the current flowing now? It's flowing that way. So you look at that, you put your thumb in the direction of the current flow towards us, fingers in the direction of the field, and it goes up. So this side would be going up, this side would be going down. It's going to spin like that, anti-clockwise, one direction of B. Explain your answer. Right hand slap rule on JK means JK going down. You need to explain it further than this, but this is the key essence of it. Right hand slap rule on LM is going means LM going up. Draw a little diagram. Maybe that's not the best diagram, maybe this diagram is better. Therefore B. Okay? Whew, I'm tired. Last question. Okay. So in parts of Victoria we have some line running horizontally from east to west. I like to get a quick visualization east to west. And there's some current. The current transmission is, so I equals 30 amps root mean squared. So you note that root mean squared, that's unusual. F's magnetic field point directly north, so the field's going north. Which of the graphs best illustrates how much electromagnetic force acting on each mire as a function of time? Sorry. Show a numerical calculation to justify answer. So what this is saying is, we know that current plus field gives us force. Okay, and they're saying, sketch this force. And the tricky thing, why is it varying up and down, is because our current isn't just flat. No, this isn't DC. This is 30 amps root mean squared. Yeah, root mean squared. Okay, so as soon as it says root mean squared, we know there's no such thing as DC root mean squared. If it's root mean squared, it must be AC. Okay, remember that? Remember, that's important to know. Okay, so once we know that, if it's AC, if the current's going up and down, then when the current hits zero, we're going to have no force. So it's going to be here. But when the current's at its peak, that's going to be the peak of our force. So what we really need to know is figure out, they want numbers, so we need to do NILB. So force equals, N is nothing, we have current. Our length is, they should tell us the length. On each meter. So our length is 1, and our field is 10, so 1 times 10 to the negative 4. But what is the current we want to put in? Well, if we wanted to put in the peak of our graph, or whatever the peak is, what we need to do is figure out the peak of our AC. And we don't have that yet. We have root mean squared. So remember, our root mean squared 30, to get from root mean squared to peak, you have to multiply by root 2 equals peak. So quickly illustrate that. Root mean squared is like the average, so the peak's always higher, so we need to multiply that average by root 2 to get the peak. So I'm going to quickly do 30 times root 2 on my calculator. So that's 42.4. So that means our peak, our force peak is our I peak times 10 to the negative 4, which equals 42.4 times 10 to the negative 4. So we just need to find that. So this is in 10 to the negative 3, so I'm going to change that to 4.2 times 10 to the negative 3. So we're looking for a peak of around 4.2 times 10 to the negative 3, and that is the top one. Okay, that makes sense? So they show different graphs here, and what they were expecting you guys to make sure, why is it not A? Because this is not DC current, we know because it's root mean squared, it must be AC. Why is it not C or D? If you plugged in 30 into here, I would imagine you would get C. And that's for students forgetting that root mean squared is not the peak, but root mean squared is this kind of like average, kind of like this average thing. And if you plug that in, you wouldn't get the peak. You wouldn't get the peak, you'd get the average, but there's no average here. So to figure out the peak of this, you need to figure out the peak current. And that's why it's B. Okay? So that's it for right-hand slap rule. I'll be adding videos later, and if you have any questions, just ask me. No worries, easy. We'll catch you guys later.